Now, when I teach students about how to add and subtract equilibrium constants, the problem I get is that I can give you a list of formulas and I can tell you these are the rules, but you typically don't get them. And you don't get them because what's going on in terms of the reactions and what's going on in terms of the equilibrium constants don't really connect to each other. So I'm going to do this in 4 videos. I'm going to teach you 3 basic rules. In the 4th video, we're going to put all the rules together, and this is going to be the first video on this. Now, these rules are very important, and you have to understand why the rules are what they are, because not only are they going to help you conceptually understand what's going on, they're going to keep you from making common mistakes. So the first rule we're going to look at is what happens when you add and subtract 2 reactions. What happens to the equilibrium constants? And what we're going to do is we're going to use the relationship we know so well, that at equilibrium, KQ equals Q. And what we're going to do is we're going to look at the expression for Q and we're going to compare it to our expressions for KQ. So let's look at 2 reactions here. We have H plus AQ plus SO4 minus 2 goes back and forth to H SO4 minus 1. All these are AQ. Our second reaction is going to be H2O, liquid, goes back and forth to H plus AQ plus OH minus AQ. Now, each of these have an equilibrium constant, so we're going to call this K1 and KW because that's what KW is. And what I'm curious is, what happens when you add these 2 reactions together? So, ignoring everything on the right in terms of equilibrium, let's just talk about how this ends up looking when you add and subtract reaction. So if we add these 2, I get H2O liquid plus SO4 minus 2, but my 2 H pluses cancel off both sides. And so I get HSO4 minus 1 AQ plus OH minus AQ. So this is my actual reaction. Now up here, if I'm at equilibrium, K1 equals Q, and Q here in this case equals concentration of HSO4 minus 1 divided by H plus times SO4 minus 2. And if I look at KW, it's H plus times OH minus. Now, I have another equilibrium constant down here. We'll call this K2. K2 is equal to Q, and Q here is OH minus times HSO4 minus 1 all over, well, I don't have H2O, so it's SO4 minus 2. So this is going to equal my expression for Q. So how do these 2 connect to this one? Well, I can't add and subtract these, so that's off the table. And you can prove it to yourself, but if you try to add these 2 reactions together, you end up getting a weird algebraic expression. You can't recover this. But let's say I call this Q1, Q2. If I take Q1 times Q2, I'll get the concentration of HSO4 minus 1 all over H plus times SO4 minus 2 times H plus times OH minus. Sorry to go off the screen there for you. So, also sorry for how bad this slants. The H pluses cancel out. And what I end up getting is this expression again, OH minus times HSO4 minus 2 times SO divided by SO4 minus 2. So this is our first rule. If we take 2 equilibrium reactions and add them together, we multiply their equilibrium constants together to get the new equilibrium constant. So if I take this reaction plus this reaction, K1 and KW, K2 here is just K1 times KW, numerically. So if I had numbers for these, I can now calculate the numbers for this, based purely off their equilibrium constants.